All right. Thank you for the introduction. So I am Jonathan Helmus, and today I'm going to be talking about scientific Python on the Raspberry Pi, which I've given the name Berryconda. So the Raspberry Pis are a series of single-board computers that have become very popular. They started out to focus on helping students learn computer science, give them a really cheap, low power, but still very performant single-board computer that they can play around with. But they've now become very popular with makers, the robotics community, and just anyone who really wants a nice little machine that they can carry around that can do some nice computation. So there's been a number of models. Started with the Raspberry Pi 1, which had a single-core Broadcom CPU that ran the 6th architecture of ARM, and it had half a gigabyte of memory. That was pretty quickly followed up by the Raspberry 2, which added a quad-core processor, which was much more powerful, and doubled the memory to a gigabyte. And then about a year later was the Raspberry Pi 3, which sped up the CPU and also added Wi-Fi and Bluetooth, which is really nice if you want just one board. You can sit on a shelf. You don't have to hook it up to your Ethernet. And if you want something a little smaller, you can also get a Raspberry Pi Zero, which is about the size of a stick of gum. And these are basically the Raspberry Pi 1, all the memory and the CPU taken from that, shrunken down into this tiny little package size, and we removed all the peripherals because you probably don't need those. And the nice thing about the Zero is it costs $5, so you can go buy one. If you want Wi-Fi and Bluetooth, that will cost you another $5, but you can get the Raspberry Pi Zero W, and it's pretty nice. So my story with the Raspberry Pi is very directly tied to Python. So in 2014, I went to PyCon Montreal, and they had a closing raffle, and I ended up coming home with a Raspberry Pi. Of course, I had to plug it in and see what it could do. I found it was really cool. You could it ran Raspbian, which is a port of Debian that runs on the Raspberry Pi. I used it to run some programs, host some servers, just kind of around my house, but it was a little underperformant than what I was looking for. In the spring of 2015, I started getting very involved with CondaForge, which is a community effort to create packages for the Conda environment and package manager. And included with this was I decided to try and build Python from source. And it turns out that Python has a pretty sane build environment. On Unix, it's just configure, make, install. And so I got really involved with that, and I really liked it because you could get the newest versions of all the packages. In the summer of 2016, I was looking for some new projects to start working on, and so I went out and bought a Raspberry Pi 3, and that really just kind of blew my mind. I didn't have to go and find my router and hook it up behind it. It had Wi-Fi built in. Having 4 processors actually was pretty impressive. It could run, for someone who started programming on really old machines, this was like better than what I started with. But I really wanted to program Python, and the Raspbian had Python, but a lot of the packages were kind of out of date. It had Python 3, but it was Python 3.4, and in 2016 you had Python 3.5, and 3.6 was kind of in release candidate, so you're like, we're getting a little behind here. And CondaForge had all those packages and had recipes to build all of them. And around this time, too, CondaForge was transitioning to using Conda Build 2. And so that to support that package, that change, we actually had to rebuild a bunch of really low-level packages to support this new longer prefix. And I was involved with that, so I'd kind of seen what goes into all that package building. And so I thought, well, could I build Conda package for the Raspberry Pi? And it turns out Continuum actually had a mini Conda for Raspberry Pi, but again, it had some older packages and not quite everything that I wanted. And then in the winter, my wife, who teaches at college, she was teaching 2 nights a week evening classes. So I had a lot of free time. So I started just building kind of everything, and it got a little out of hand, and so I had to give it a name. So I started Berryconda, which is a Conda-based Python distribution for the Raspberry Pi. It's designed to work on Raspbian Jessie. it might work on older versions, but in all reality, it's really easy to upgrade to the latest version of Raspbian on the Raspberry Pi. You just reflash a SD card. There's mini conda-like installers for both ARM6 and ARM7. So the ARM6 ones work on the Raspberry Pi 0 and 1s, and the ARM7s on the 2 and 3s. These come in both a Python 2 flavor and a Python 3. And there's actually over 200 packages now that have been built. So this has all your standard scientific Python stack: NumPy, SciPy, Matplotlib, Jupyter, scikit-learn. If you kind of consider it core, and a lot of people here do, then it probably is in there. If you have a different definition of what's in the scientific Python ecosystem, it might not be. And all of these are available for both Python 2, 7, and Python 3.5 and 3.6. And they're also compiled, if it uses the NumPy API, against the last 2 versions of NumPy. All the recipes that are reused, the majority of which came from CondaForge with just slight modifications, and the tools that are used to maintain Berryconda are all on this GitHub website, and all the packages are stored on the Anaconda cloud. So with all those packages, there's a lot of applications that are possible with this. And just a few of them that I kind of thought of is you can go buy a Raspberry Pi, install Berryconda on it, and run Jupyter. You get the latest version, and you can just run that, have that running 24/7. If you want to do a little bit of work, you open up your web browser on your laptop, log into the node, and run some calculations, and when you're done, you close it, and you can come back later, and it's still running. The Raspberry Pi Zeros especially are really nice for like a remote data collection device. They use almost no electricity, so you can usually power them with, if you have a USB port somewhere around, they work fine. The W has Wi-Fi, so if you need to send back data. And by being able to install Berryconda, you can have your standard kind of scientific Python stack to do some data processing or data reduction so that you have less data to either store or send back to your server. It also makes a nice little lightweight development server. So I have one that just kind of sits in my house, and if I want to check out some pull requests that somebody worked on, or run a quick test, I can just log into that, and I don't have to have a big server running anywhere. It also works as a nice little test machine for the ARM architecture. So just like it's very beneficial to test your software on different versions of Python and different operating systems, to try and find some bugs. It's also very helpful to try it on different machine architectures. And one of them that I found actually was there was a test in the NumPy 112 release candidate that was failing, where a floating point NAND was being somehow cast very strange on the PowerPC, and some of the unit tests were actually failing. And it turns out this actually, I could replicate it on the Raspberry Pi, even though it uses an ARM architecture. And what it turns out to be is casting a NAND to an integer is an undefined behavior in C. And the unit test in NumPy was kind of through some strange ways, actually depending on the way that casting occurs in Intel's x86 implementation. So it failed on these other ones, and that's now been fixed. So with all these possible applications, it's very important that Berryconda have the latest versions of your software that you're interested in. And this process is kind of, can be a little complicated. So when new software is released, when new versions are released, the recipes that are used to make these conda packages have to be updated, and then we also have to build those. In addition, as new software kind of enters the scientific Python ecosystem, recipes for those packages have to be sourced. Usually I look on CondaForge or Anaconda recipes. Also, as new dependencies sometimes enter some of our favorite tools, those also have to be built. In addition, when a new version of Python comes out, a lot of times a lot of packages have to be rebuilt to support that new version. Also, new versions of NumPy require package creation. And I build all these packages on actual Raspberry Pi hardware. So initially on the Raspberry Pi 3, because that's more powerful, I can test out the recipe, make sure everything works. And then once I'm pretty sure that this is going to work, I can run it on a Raspberry Pi Zero. But scientific Python moves pretty quick, and sometimes there's a lot of new releases of software, and so sometimes the package building backlog kind of gets long. And I didn't really like this, so I tried to figure out how can we speed that up? How can I build packages faster? And there's a couple ways you can do it. The first thing is you scale out. So you just go and buy more Raspberry Pis and, buying a second one. So you soon start to get a little collection. And the people at Micro Center come to really like you. But unfortunately, this doesn't quite, at least for me, after I have about 5 or 6 SSH terminals open, building software, I start to get confused about what I've built where. And so even though hardware scale is really good, I don't think the human mind does. So I needed some other things. So one of the things that I found that takes a lot of time is finding what packages or what software was out of date, and then also modifying the recipes with those new versions and new requirements. So I automated that process. So in Berryconda, there's now a script that will go look on the Python package index and compare the versions of the packages up there against those in the Raspberry Pi repository. And any packages that are out of date, it'll give me a little list. And so this runs really quick. I usually start this when I make my coffee in the morning. And then I also have a script that will update the recipes to the new versions and update the cryptographic hashes that we use to make sure that the packages are downloaded correctly. And so then with this, it's just launching some builds, which is a little bit, it is a time-consuming process, but not that bad. But even with those two tricks, it still was kind of taking a while. And so I wondered, could we just reduce the number of packages built? And one way is, I could just support fewer versions of Python, or, just say, well, maybe you want Dask, but I don't really want to build that. It's really complicated. It's got a lot of dependencies. But that didn't really seem like a worthwhile endeavor, because I really wanted to give people like a first, make Raspberry Pi a first-class citizen in the scientific Python ecosystem. But Conda, in the 4.3 release, which was released earlier this year, introduced a new type of package called no-arch Python packages. And what these are is for software that's written in pure Python and doesn't have any dependencies for different platforms or different versions of Python. You can build a single package that can be installed in any Python version on any operating system on any platform. And so whereas previously for Berryconda, I had to build 6 packages because we have 3 different versions of Python on 2 different platforms. I can build a single package and it will work in the same manner. So this actually, of the about 200 packages, about 25% can be covered by no-arch packages, and probably some more. I just don't go and try to build a no-arch package until there's a new version. So with these speed up, I actually ended up having a lot of more free time. And so of course I got a little bored, and so I kind of started thinking about Berryconda some more, and I say, the tagline on GitHub is it's a conda-based Python distribution for the Raspberry Pi. And I started thinking about this, and well, it does use conda, and it provides, Python, but I don't know why it needs a Raspberry Pi. I mean, really it's just running on Linux, and the Raspberry Pi is nice, but it's really just an ARM machine, so maybe we don't really need a Raspberry Pi. Maybe Berryconda is really just a conda-based Python distribution for the ARM architecture. And so I wondered, is this true? Where can I go get some ARM machines? And there's actually ARM CPUs in a lot of consumer devices now. And if you look around, you can do some Googling. And I was like, I wonder if I could get in on a laptop, because that'd be really cool. So this laptop here is actually a Asus C201 Chromebook. It has a quad-core Rockchip ARM7 processor. 4 gigabytes of RAM, and it runs Chrome OS. You can't kind of really get away with anything other than that. But you can run Crouton, which allows you to then do a Linux change root so that you can run Ubuntu, the latest LTS, or you can run Debian, and you go and grab the Raspberry Pi, or the Berryconda installers, and they just work. And then you can go and install NumPy, SciPy, your entire stack. You can use Jupyter. This has actually kind of been my go-to machine now that I've installed everything, because it has about a 13-hour battery life and weighs 2 pounds. So if I'm going to go to a meetup or something that I'm going to be very mobile, I'll just grab this instead of a more heavy MacBook Pro or something. Plus, it's $170. If it did get damaged or something, I wouldn't be as sad. It's also pretty performant. So Python 3.6 takes about 8.5 minutes to build on this machine, whereas that's about twice as fast as trying to build it on the Raspberry Pi 3, which takes about 17 minutes. I will say, though, if you go and buy this, the screen is a little lacking. So I had a Chromebook now, a laptop that would run Raspberry Pi, or Berryconda. I thought, what else can I install it on? Well, like a number of us here, phones tend to have ARM chips. And I didn't really want to, take my phone that I use every day, but I had a Nexus 4 that I had laying around that wasn't doing anything, and it turns out that has an ARM chip. It has a Qualcomm quad-core processor, 2 gigabytes of RAM, and you can actually get a version of Ubuntu that will install on this, called Ubuntu Touch. It's not really supported anymore. I think they stopped supporting it, but all the install instructions and the installers still work. And yeah, you can then just open up a terminal and install Berryconda, and it works fine. Of course, the next thing I wanted to do was install Jupyter, and that also works. And so then I started up a Jupyter notebook. You jump to the browser, and you type stuff in, but I noticed nothing was coming out of the terminal. Nothing was coming out on the notebook, and I was like, what's going on? Well, as soon as the terminal goes into the background, the phone is trying to save some power, so it doesn't allow that process to run anymore. So what you got to do is just jump between the two, let the process run in the terminal, and then jump back to look at your result. So you kind of can, but also the Nexus 4 is not really a great development machine. So Python 3.6 takes about 50% longer to build on the Nexus 4 than on the Raspberry Pi. So it's a nice trick, but I wouldn't actually suggest anyone use this as their development machine. So after a laptop and a phone, I thought, what else can I do? What else runs ARM? And a bunch of these set-top boxes that you have runs them. And I kind of wanted something really weird that nobody would be like, oh, I've already done that. So you can just go on like Alibaba and find all kinds of them. So this little thing is a Geekbox. It has an 8-core, which sounds really cool, but we'll see later it's not. An 8-core AArch64, and you can get 2 gigabytes of memory, or 2 gigabytes of RAM. And the nice thing about this thing is you can get Debbie and Jesse, and it just kind of works. You can install it. It has Wi-Fi built in. It has actually has an eMMC, so you don't have to worry about an SD card. It's really, and I think it's like $70. It's not bad. And with a little bit of work, you can run a version of Conda on it. It takes a little bit of work, but unfortunately, the build time is about 14.5 minutes. So even though it's got 8 cores, and yes, Python does try and take advantage of multi-cores when it's compiling, it runs about the same as a Raspberry Pi 3. I'm not sure why, but so having installed Berryconda on both a laptop and a phone, and this little set-top box, I'm really hoping that I've convinced you guys that Berryconda really is a Conda-based Python distribution for ARM-based systems. But you're probably just going to install it on the Raspberry Pi. So with any remaining time, I'm very happy to answer any questions. If you want more details on this project, you can go to this GitHub website, and I'm really also happy to answer any questions over email. Thanks.
All right, questions? Was there somebody else with a microphone in the room? Okay, I guess I'll be running around. No, wait for the mic.
Do you have OpenCV working on there? Is that in your list of things to do someday?
No. If somebody, well,
I have installed it on a Raspberry Pi.
Yeah,
but
I know it can be installed
time.
on the Raspberry Pi. I just, if there's a Conda forge recipe, I probably could make a build.
Yeah.
I know OpenCV can be configured in a number of ways, and it's which way do you want it is probably a good question.
Yeah. Okay.
Okay, over here, coming to you. Wait for the mic.
So what are the prospects for officially supported ARM builds from Continuum for Anaconda?
So actually, after starting this work, I now work for Continuum. I don't think that had anything to do with my hiring, but We will have to discuss it internally. Right now, I kind of do some things that are, if I break things, I don't feel as bad as if this was actually an official Continuum product.
So what are the next devices you're trying to install Berryconda on? And is one of them going to be a smart fridge?
So no smart fridges. The one that I'm really excited about is, so NVIDIA makes some GPU development boards. So they're the Jetson TX1, 2, there might be another one. And those actually run, the earlier ones ran the ARM7 chip, and now they're actually moving to a 64-bit AArch64. And I'm really excited. I have access to one of them. I just have to start building things. And those are pretty, those have like 8 gigs of RAM and run just about, like a real computer.
More questions? Raise your hand so I can run to you. Last chance? Okay, if there's no more questions, please put your hands together.